2.5 variations. So 2.5, the concepts, a lot of the concepts will come back in chapter 6, especially 6.6. 2.5 is going to teach us how do we tackle word problems, how do we get better, how do we break down sentence by sentence. So let's talk about variation. There's a few types of variation. Our first type is varies directly, directly proportional, and constant of proportionality. So x and y denote two quantities. That just means you're working with an x, you're working with a y, you're working with apples, oranges, you're working with two different things. If that's the case, if you have x and y are two different items, y varies directly with x, or you can say y is directly proportional to x if there is a non-zero number k for which y equals k times x. K is called the constant of proportionality. So if you see the phrase varies directly or directly proportional, that actually means multiplication. If y varies directly with x and x is greater than 0 and k is greater than 0, then the graph below illustrates the relationship between y and x. Note that the constant of proportionality is in fact the slope of a line. So lines are direct variation. All right, how do we set up variations? And this is for all types of variation we're going to talk about in 2.5. So this is usually how we set them up if we have 3 sentences. If we have more than 3 sentences, though, you can still use this method and you can start to pick out those details. So usually for a variation example, the first sentence, that's going to set up your variables. So like what, instead of x and y, what do I use? The second sentence is used to find k and the model. If you're not given k, you need to find it, and then that's going to give you the model. That's going to give you the formula to work with. If you're not given k, it will literally not be said you're given it. How it's said, it will say the constant of proportionality is this, or k is this. We are not going to be given it today, so you'll see that. Your last sentence, that's usually the question. That's the question we're trying to answer. So these are 3 steps to tackle a word problem with variation and a lot of other things. If you just use this method, it's going to help with all types of word problems. Mortgage payments. The monthly payment P of a mortgage varies directly with the amount borrowed B. See that first sentence? If the monthly payment of a 30-year mortgage is $7.33 for every $1,000 borrowed, find the formula that relates the monthly payment P to the amount borrowed B for a mortgage with these terms. Then find the monthly payment P when the amount borrowed is $280,000. All right, so our first sentence usually is going to set up the variables. So this is our first sentence from here to here. That's our first sentence. All right, hopefully it like jumped out to you when I said it. The phrase varies directly. Varies directly, that tells me y equals k times x. That's literally what it tells me. So whatever comes to the left of that phrase, that's your y. Whatever comes to the right of that phrase, that's your x. So if we look to the left of this phrase, the variable they give us is p. So we'll have p equals. To the right of what they give us, we're given b. So that's what x equals. K is always K. It doesn't change unless it's given. It will literally say constant is this, constant proportionality is this, or K equals this. So we just put it there. That means we must find K because it's not given. Just as a reminder, P, that represents payment, and B represents money borrowed. So you see how the first sentence, it literally set up the variables to use. The second sentence, that's how we find K and the model. So if the monthly payment, I see their payment on a 30-year mortgage is $7.33 for every $1,000 borrowed, find the formula that relates monthly payment to the amount borrowed. So it told us that our payment is 733. Remember, payment is money, that's why it's 733. So P equals 733, and the amount borrowed is $1,000. Let's plug it in. So our payment is 733. That's going to equal the amount we borrowed, which is 1,000. And that's going to leave us with K. That's going to leave us with K because that's what we need to find. So to solve for K, we're going to divide by 1,000. And when we do, we get 0.00733 equals K. We can actually have the model now. The model is our payment equals the amount borrowed times our constant. Our constant is 0.00733. So this is our formula we're going to use to actually answer the question. You see how sentence 2 actually set up our model and finding K. So our sentence 2 is from here to here. Now the actual question. Find the monthly payment. So we're trying to find P. We don't know it. When the amount borrowed is $280,000. Let's plug it into the model. So we have P, which we're trying to find, equals the amount borrowed, which is 280,000, times our constant of proportionality, which is 0.00733. Use your calculator. We get our payment is 2052.4 per month. Meaning, if you bought a house for $280,000 and your interest rate was 0.00733, aka 7.3%, then you would pay $2,500 per month, literally just your mortgage. That doesn't count for your homeowner's insurance, your PIP insurance, or anything else. Another type of variation is inverse variation. So we're going to let x and y denote two quantities. That's saying you're just working with two things. So this time, though, the phrase we're looking for, y varies inversely with x, or y is inversely proportional to x. So inverse is division. This graph represents inverse variation, kind of like swoops down a little bit. We're still going to use the 3-sentence breakdown. So, maximum weight that can be sorted by a piece of pine. The maximum weight W that can be safely supported by a 2-inch by 4-inch piece of pine varies inversely with its length L. Experiments indicate that the maximum weight of an 8-foot long 2x4 piece of pine can support 400 pounds. Write a general formula relating the maximum weight in pounds to the length L in feet. Find the maximum weight W that can be safely supported by the length of 20 feet. So our first sentence gives us variables. And it says varies inversely. Varies inversely tells me division. It tells me y equals k over x. Whatever comes to the left of that phrase varies inversely, that's your y. So the variable that comes before is w. So our y actually is represented by weight. K is always k, you just put it there. And our x, it comes after that phrase varies inversely. And what comes after is length L. So it told us w equals weight, and L equals the length. All right, let's move on to our second sentence. Our second sentence, that's what sets up our K. So it told us experiments indicate that the maximum weight that an 8-foot long 2x4 piece of pine can support is 400 pounds. So we have the weight. It's 400. K is just K because we need to find it. And the length, it says the length of the wood, it's an 8-foot long. 2x4 is just the thickness of the wood. I don't care about that. We need the length of the wood, which is 8. We need to solve for k. In order to solve for k, we multiply by 8. And when we do, we get 3200 equals k. That means our model is W equals 3200 over the length. So writing a general formula, that's what we just did. So you see how this is 4 sentences, but that sentence doesn't mean anything because we already did the formula. Let's move on to the last sentence. The last sentence is always the question. So our last sentence, we have find the maximum weight. So that's what we're looking for straight up. Find the weight. So we're looking for W equals our constant, which is 3200, over the length. So what's the maximum weight that can be safely supported by a length of 20 feet? 3200 divided by 20, we get 160 pounds. The max weight of a 20-foot 2x4 is 160 pounds. We have one more type of variation. It's called, well, it's when we put both. It varies jointly. When a variable quantity q is proportional to 2 or more other variables, we say that q varies jointly with these quantities. In joint variation, combinations of direct and/or inverse variation may occur. So we could have multiplication, we could have division, we could have both. Let's just see as we work through it. Modeling a joint variation loss of heat through a wall. The loss of heat through a wall varies directly with the area of the wall and the difference between the inside and outside temperature, and varies inversely with the thickness of the wall. Write an equation that relates these quantities. So there are no variables, there are no numbers. So here we're just creating a model to represent this information. We don't even have variables, so we actually need to start bringing out things to say, okay, this means this means this. So the loss of heat through a wall, that's a pretty darn important thing. Why? Because if we keep reading, varies directly. So that comes before the phrase varies. So that's an important detail. So loss of heat, let's say that's L. Then we see varies directly. We know varies directly stands for y equals k times x. Then we have the area of the wall. Area of the wall, we can say A. And difference between the inside and outside temperature. So that's temperature difference. Let's say that's T. And varies inversely. So varies inversely, that tells me somewhere I'm going to have division with the thickness of the wall. That's an important thing. So thickness, I did D because thickness is a distance. You can use any variable you want, but I use D. I can't use T because we already used it. You can use W for wall, but I use D because it's technically a distance. So now that I have what variable is supposed to be what, I'm going to reread it and just write out the variables that I'm reading. The loss of heat, that is L. Varies directly, that means equals. Area of the wall, that meant A. And the difference between the temperature inside and out. So because this is varies directly, and what comes after is after A is another variable, and means multiplication. It doesn't mean plus in this case. Variation is either only multiplication or and or division. Never plus or minus. It is only multiplication, division. So we have the difference of the temperatures, so that's T. and varies inversely. Varies inversely stands for a fraction bar. The thickness of the wall, we said that was D. The only thing we're missing is K. K will always go on top, or you can slap it to the side. So this can be your model, or you can say L equals ATK over D. Both are the same. The force of wind on a window. That's so applicable to Florida, right? The force F of the wind on a flat surface positioned at a right angle to the direction of the wind varies jointly with the area A of the surface and the square of the speed V of the wind. A wind of 20 miles per hour blowing on a window measuring 3 feet by 4 feet has a force of 120 pounds. What force does a wind of 40 miles per hour exert on a window measuring 4 feet by 5 feet? All right, again, because we have numbers and variables here, we need to identify things and bring them out. So we have this key phrase, varies jointly. So varies jointly means we could have division, we could have multiplication. Let's just see what happens. So our first variable we see is the force of the wind. Then it varies jointly. So varies jointly, that could be multiplication or division. We just have to keep reading. With the area A of the surface. So A equals area of the window. Then we have and the square of speed V. So V equals wind speed. And that's our first sentence. So our first sentence sets up the variables. Now let's reread it and get our model going. And find K, because it didn't give us K. So it says F varies jointly. Right now that just means equals. Area A, so that represents A. And there is no varies jointly yet, so I just keep writing next to it. And means multiplication or division. But since there's no jointly word, we just keep writing next to it. So we have A and the wind speed. It says the square of speed V. That's a weird way to say V squared. That's actually how you say V squared in math. V squared is math English. The square of V is English English. And then we don't have K. That's the end of the first sentence, so we just slap K next to it. So we have to find K using this model. Even though it says varies jointly, it does not always mean division. That's why we just have to keep reading. And remember, and, it just means put it next to it. So our second sentence, that's going to give us numbers to find K. A wind speed of 20 miles per hour. So we have V, it's 20. Blowing on a window measuring 3 feet by 5 feet. So 3 feet by 5 feet. On that window, we have to find area. So 3 times 4, we get 12. So our area, our A, is 12. And it has a force of 120 pounds. That means F, that's for force, which is 120. Let's plug it in. We have 120 equals our area, which is 12. Our wind speed, which is 20 squared, all times K, which is what we're trying to find. 20 squared times 12 is 4,800, all times K. We divide by 4,800. 120 divided by 480, we can simplify that down to 1 over 40. So our model is going to be F equals A V squared times 1 over 40. You can rewrite that to make it look better because to me that looks a little weird. I want to rewrite this as AV squared over 40. Because remember, there's a 1 there, so we just multiply straight across. That's why it goes on top. It does not matter though. All right, our last sentence is the actual question. What force does a wind of 40 miles per hour exert on a window measuring 4 feet by 9 feet? So we're going to use our model. And let's go ahead and figure out what we have. We have wind of 40 miles per hour. So we have our V of 40. And then it says the window measures 4 feet by 5. So we need to find the area of that window. So 4 times 5, we get 20. Let's plug it in. Force equals area, which is 20, times velocity squared, which is 40 squared. And that's all divided by 40. So 40 squared times 20 is 32,000. 32,000 divided by 40 is 800. Now, what does that mean for us? The force of wind blowing at 40 miles per hour on a 4 foot by 5 foot window is 800 pounds. 4 foot by 5 feet is not that big of a window. So if it is 40 mile an hour winds and it's hitting the window, that is 800 pounds of force.